Hi and Assalamualaikum. My name is Muhammad Haidir bin Hamdan and my supervisor is Dr. Nofrizalidris bin Darlis, and my project's title is Sloshing Effect on flexitank using CFD. Proceed with the first slides. Research background. So flexitank is an efficient and practical solution for freight market in liquid bulk transportations. In liquid transportations, flexitank used to transport non-hazardous liquid substances such as lubricants, latex, and also food products such as fruit juices and wine. So previously, in liquid transportations, they transporting liquid in bulk by using the ISO tank. But when the flexitank invented, they prefer to use flexitank as it is disposable, easy to care and handle. And previously also they shipped liquid in bulk by using the heavy duty reverse bladders, but it is quite expensive where it costs around $5,000 for a piece, and it is not an economic solution. So when it comes to liquid transportations, the primary concerns are on the sloshing effect. So sloshing constitutes a broad class of problems of great practical importance concerning on the safety transportation systems, such as the tank trucks on highway and liquid cargo in the ocean tank. So when a tank is partly or partially filled, the liquid tend to slosh violently due to certain motions. So through the violent liquid movement, highly concentrated pressure would have been created on the walls, and it can cause structural damage and also affect the stability of the container vehicle. This project aims to study the sloshing effect of flexitank by using the CFD. CFD is a branch of fluid mechanics that uses numerical methods to solve and analyze problems involving fluid. So it can help us to gain a better vision on the sloshing behavior and study the effect of sloshing. CFD also provide insights of the new designs product before prototype are being made, which will lead us to cost reduction in the research and development of a product. However, there are some cases reported on the leakage of the flexitank during the transportation. This is because of the sloshing effect happen during the transportations. There are also some cases where the structure of the container vehicle also damaged due to the massive liquid sloshing during the transportations. Users or industry players that use flexitanks to transport their goods or products also made a complaint on the leakage incidents, as if there is a leakage incident happened due to their products transporting, they will have to bear the losses, as they will need to consider that their products as a total loss, as their products have exposed to the contaminations and also spread all over in the container vehicle if there is a leakage occur. So even though they have transport their goods and products, but based on the suggested capacity, which is in the market, the maximum is 24 cubic meter, there are still leakage incidents happen. So is it the 24 cubic meter is the optimum capacity of the flexitank or not? So this issue may comes from the manufacturer. So maybe the manufacturer had to tackle the critical points during the sloshing in the flexitank, as they were experimenting and prototyping using the conventional way. So by using the conventional way, it is also time consuming and also expensive, as they will have need to have actual prototypes of the products for the experimenting or research and development. So besides that, conventional way also give the manufacturer hard to tackle the critical points, as there are lacks of details on the internal flow motions of the sloshing in the flexitank. So the main problems in this study is the lack of details on the internal flow motion inside the flexitank and the optimum capacity with minimized sloshing effects still unsure. So proceed to the objective. So objective of this project is to study the effect of sloshing in the flexitank due to linear motion and to analyze the maximum value of flexitank's capacity. So scope of this project, the region of this study is focused on the flexitank with 20 feet container, and the simulation speed and capacity was set as follows. The speed are in range of 10 meter per second to 25 meter per second, and the capacity was set to 24 cubic meter plus minus 5, 10 and 15%. And the capacity was set as follows. There are 6 capacity that will be simulated. And then third, the geometry modeling was created by using CAD software SolidWorks 2019, and the analysis and data establishments of the sloshing effect of flexitank use CFD, which is SolidWorks 2019 flow simulation. So now we continue with the literature review 1, freight transportation. So from the first study, it states that ocean tanker is a time-consuming mode of transportation, and it might take up to months for products to be delivered. Besides, ocean tanker is a reusable tank. Abundant transfers raise the possibility of risk of product contamination. And then second study shows that incurring costs for the cleaning after unloading will need to be borne by the shippers. Besides, the risk of contamination also will be high if the cleaning work inefficient and due to abundant unload. And then third study shows contamination during the transportation of the products in liquid bulk. This type of tank will result in high operating costs due to the time required to load and unload items. And last, by A.L. Tonen 2015, flexitank is a one-way transportation method as the flexibank is not reusable, making the contamination risk of the products low. So as the summary for this literature review, most of the freight transportation option is available as reusable. Concern raised among users are the risk of contamination of the products. Lightweight, practicality and economically of flexitank are the traits that make users and shippers prefer flexitank as a carriage of the products. So literature review 2. First study states that flexitank may carry between 10,000 and 24,000 liters. Generally, larger capacity models will be used. Second study states there are some cases to be reported that the package of flexitank found to be damaged and leakage upon arriving at the port. And third study shows that state that this damage range from minimal deformation and buckling to structural damage, which necessitated the containers and cargoes write-off. So as the summary, in market, the most used capacity of flexitank is 24 cubic meter, and it is claimed as the maximum capacity available in market. However, the leakage of flexitank during transportation still occurs. Therefore, 24 cubic meter might be not the optimal capacity of the flexitank with fewer effect of sloshing. So literature review 3, hydrodynamic analysis. First study simulate a tank with a speed profile of 10 meter per second and capacity of 40%, and is analyzed pressure distribution on the tank surface. Second study analyzed the liquid sloshing behavior with and without baffle. The tank was simulated by giving an acceleration of 9.81 meter per second. And then third study analyzed the effect of slosh and energy balance during the slosh by simulating the tank with sudden brake from the speed of 30 meter per second. And then fourth study analyzed the average pressure and average temperature inside the tank, simulating with constant speed 11.11 meter per second and decelerating 2.943 meter per second. And last, analyze the natural frequencies, forces and moments influenced by slosh, simulating the tank with different volume, 30%, 50% and 70%, with speed of lateral 1.93 and 4.34 meter per second square, and longitudinal 0.5, 0.89 meter per second square. So as a summary of this literature review, many studies of sloshing within tank are done by using the CFD. The studies show that field level may influence the effect of sloshing to the tank. Hence, the study study the optimum capacity of the flexitank, vital in order to diminish the sloshing effect. Therefore, CFD is the best method to study the behavior of slosh and to analyze the hydrodynamics analysis. Literature review 4 on CFD. So in the table it shows the software that used by previous study and the boundary conditions set in the simulation. So the plan for this study, the CFD software that will be used is SolidWorks flow simulation with 3 velocity profile of 10 meter per second, 30 meter per second and 25 meter per second, and the speed profile as shown in the figure, and the capacity for the simulation as stated in the table. So next we proceed with the methodology. So on the slide shows a flow chart of the methodology for this project. So the first one is with the literature review. Next is geometrical modeling. So this is the geometrical modeling for this project and the meshing, and then the boundary conditions. So this is the boundary conditions for in the study. So for the present study, we use SolidWorks with velocity of 10 meter per second, 50 meter per second, and 35 meter per second, with the profile speed as shown in this figure, and the capacity of 24 cubic meter plus minus 5, 10, and 50% as stated in the previous slide. So the type of flow in this study will be the transient states. And next, flow simulation, which is using the SolidWorks flow simulation, SolidWorks 2019 flow simulation, analysis of results also using the same software, and lastly the documentation. Okay, next we proceed to the preliminary results. So firstly, we will go on the free surface. Normally free surface will be analyzed by the sloshing behavior. So this is the video sloshing presented the sloshing behavior due to the motions obeying to the speed profile. So in this video it shows the motion under 10 meter per second. So we can observe that during at time equal to 0 seconds, the flow is at a steady state as there is no speed applied, and obeying to the profile speed, the speed start applied at 5 seconds. So we observe at t equal to 10 seconds, which is at peak of the velocity, we can observe that the fluid hits the front walls of the container. The velocity start to decrease at 15 to 20 seconds, and it can be observed at t equal to 20 seconds that the fluids hit the back of the walls of the container, and it starts to stabilize after 5 seconds stop, fully stop, which is we can observe at t equal to 25 seconds the fluids have stabilized and no massive liquid sloshing. So next on the shear stress. So in this slides it shows the graph and the contour of the shear stress on the flexitank. So from this contour we can prove that sloshing are leading to the structural damage and also leakage in the flexitank. As we can see at the contour, there are some points that have higher value of shear stress. So next is pressure. So large amplitude sloshing caused by the excited tank may result in a liquid impact on the roof and the walls. So from pressure we are going to observe the liquid impact of the fluid to the roof and the walls in the flexitank container, the container's body. And from the contour we can observe that the pressure, concentrated pressure are high at the bottom front of the flexitank container. So this also can lead to the structural damage and also leakage of the flexitanks. So as the conclusions, the main objective of this project is to study the effect of sloshing in the flexitank due to linear motions. This study is really significant, and the parameter as stated in the boundary condition will be observed. Preliminary results from this study prove that sloshing can lead to structural damage and leakage of the flexitanks. So the study need to be proceed with the detailed study according to the parameters stated in the methodology to discuss the analysis in the future study. So that's all from me. Thank you.